Okay, so now we're going to talk about ogives, ogive graphs. Ogive graphs are just a fancy word for a cumulative relative frequency graph. Okay, we learned a little bit about that in our module. Before we get to an ogive, specifically an ogive and how it's related to a cumulative relative frequency graph, ogives basically show percentiles. Cumulative relative frequency graphs are actual ways of reporting percentiles, and you've heard of percentiles before. The NWEA tests, a lot of standardized testing, will place you in a percentile. So will your pediatrician. When you were growing up, your height and weight was always given to your parents in terms of a percentile. My oldest daughter, Haley, her height was always in like the 90th percentile, which means what? It's just a way to place an individual in a set of data, to locate them, right? Where are they in relationship to everybody else in the data set, right? So the definition of a percentile, the pth percentile of a distribution is the value where p% of the observations are less than it. Okay? In other words, for Haley to be in the 90th percentile meant that 90% of kids her age were shorter than her. Of course, that means that there were 10% of the kids her age that were taller than her. So she's taller than 90% of the kids that were her age. That's how a percentile works, right? And so this definition, again, is the percentage of individuals or data points that are less than our particular data point. Okay? Oops. Sorry. So, for example, Jenny earned a score of 86 on her test. How did she perform relative to the rest of the class, right? And so this is what's called a stem and leaf plot. We'll talk about these later. But basically, this row represents a score of 67. This row says that we have scores of 72%, 73, 73, 74. So the left side is the tens digit. The right side is the ones digit for our data points. Okay? And then we line them up in order according to their ones value. Right? So anyway, we'll talk more about those later. So those are the scores. How did she perform relative to the rest of the class? Right? Well, she scored an 86, which means that puts her right there. Right? So, how many people scored less than her? Well, there's one here with the 85, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 students scored less than her. And you can count them up, but there were 25 students overall. So if you divide that out, that gives you 0.84. That means that she's in the 84th percentile, which means that 84% of the students in the class scored less than her, scored worse than her on the test, right? So maybe a decent way to look at your test scores. Okay? And so this is just same thing typed out. All right? Now, how does that relate to the cumulative relative frequency graphs that we've looked at so far? Well, a cumulative relative frequency graph, or an ogive, is just what we use to display the cumulative relative frequency, right? That's the percentile. That's what a cumulative relative frequency is. It's pretty much a percentile, right? So here is the age of the first 44 presidents when they were inaugurated. Okay? And we'll get back to our texts in just a second. Okay, so what we got? Well, we have ages in this column, the frequency in this column, and we created these frequency distributions before. We have the relative frequency in the next column, right here. And then we have the cumulative relative frequency in the next column. Remember, cumulative frequency was a rolling total, right? So when we had two data points, so two presidents were between the ages of 40 and 44. Then we had 7 that were between the ages of 45 and 49. A cumulative frequency means that we're going to just count up to see how many were that age or younger. So 7 plus 2 is 9, so that means we've got 9 presidents that were that age, in that age group or younger. So it's a rolling total, right? And then last but not least, we have a cumulative relative frequency where we take that number in the cumulative frequency column and divide it by the total number of observations so we can come up with the percentages, right? Well, these percentages are percentiles, right? So if a president lands, was inaugurated between the ages of 40 and 44, then they would be in the 5th percentile, right? Because that means that 5% of the presidents were younger than them when they were inaugurated. Kind of the same way throughout all of this, right? If a president lands in the lands in this between 50 and 54, then depending on where they were in that interval, right, we have to know exactly where the individual sits. But that would mean that if they were maybe, say, 54 years old, then that means that they were in the 50th percentile, and 50% of the presidents were younger than them when they were inaugurated. So if we take these cumulative relative frequencies and plot them, right? Let's see, at 40, we're at 0, right? And then at 45, that starts the next class. So that should put you at the 5th percentile, so right there. And then at 50, the start of the next class, right, there were 9 individuals that were less than that. So that gives us this percentile, which is the 21st percentile. And percentiles are always listed in terms of whole numbers, right? At 55 is the start of the next class, so that puts us at the 50th percentile. And then so on and so forth. 60 puts us at the 77th percentile, and then the 93rd percentile, and then the 100th percentile, which you might get to or might not define to be in the 100th percentile, depending on how you define percentiles. Not everybody defines them the same way. No, can't talk. Okay, so that is your cumulative relative frequency graph, also known as an ogive. Okay, so here's the ogive again. Some questions that you can answer. Was Barack Obama, who was inaugurated at age 47, unusually young? Well, you got to find 47 on your x-axis because your ages are along the x-axis. And then the cumulative relative frequency, or the percentile, is along the y-axis. So there's 47. So you touch the graph there, and then you slide over to the y-axis. And it shows you that Barack Obama was in the 11th percentile. That means 11% of the presidents were younger than him when they were inaugurated. It's not a lot, right? So was he unusually young? Sure he was. Now estimate and interpret the 65th percentile. So 65th percentile, we've got to find 65 on the y-axis, slide over to the graph, and then slide straight down. And we find ourselves at about 58 years old, right? So 58 years old would place someone in the 65th percentile, right? That means that 65% of U.S. presidents were younger than 58 when they were inaugurated, Okay? So, just some ways that we want to analyze an ogive graph, right? So, let's say we want to find the median value. Now, we've switched graphs. This is test scores for a particular test, right? The median, which you may remember from your earlier math classes, median is the middle value. It's the value in a data set where half of the observations are less than that and half the observations are more than that. So, if we go and find a test score of, say, what looks to be like, and we got to watch our scale here, 20 means this is probably 20, let's see, 30, let's see, 1, 2, 3, 4. So 30 is about right there. So this probably puts us at about 44%, less than that, something like that. So this might be 44% as a test score. That puts you at the median, right? Because you slide over and you see the 50%. So the 50th percentile, or the test score, where half the class scored less than that, would be about 44%. Okay? It's kind of how you interpret that, right? So, again, if you scored, say, or if you wanted to find out what test score place someone in the 91st percentile, right? So if you think about your grades as a percentile, 91 or 90% is an A minus. So 90% would be about right here. And that test score would come straight down. And so what? About 82%. An 82% on the test would put you in the 90th percentile. So if you're looking for a curve, an 82 should be an A, right? If you're looking for a curve. But that's kind of how those work, right? And so we looked at how to create them. If we go back to our text message data, and that's what we have in our notes here, we've got our tallies, our frequencies, and our relative frequencies, right? And we want to come up with our cumulative frequencies, right? Running totals. So there's 9 in the first group, 11 in the next, so that means that there's 20 in the next group or less, and then 4 in the next group, that means that there's 24 in that group or less, and we just keep a running total. Right? So we get those values. Your relative cumulative frequency is just taking those numbers and dividing it by your total of 32, right? So again, we've done this already. 9 divided by 32 will give you that percentage, and so on and so forth, all the way down the list. Okay? So that's your table filled in again. Now to create your ogive, we just want to take the edge of each class and plot the frequency there, right? So at 50.5, we need to be at about 28%, which is where that dot is, right? At 100.5, we need to be at about 75. Sorry, at 100.5, we need to be at about 63%, which is why we made that dot. At 150.5, we want to be at 75, so we put a dot there, so on and so forth. At 200.5, we want to be at 84%, so right here. At 250.5, we want to be at 94%, so right there. At 300.5, we want to be at 97%, so right there. And at 350.5, we want to be at 97% again. And then we're all the way up to 100%. And then you try to fit your ogive the best you can to those data points. And there you go. Okay, that's how you create an ogive. Now reading it, right? In our text messages, How many text messages a day do you need to send in order to find yourself at the 50th percentile or the median, right? So again, you find 50% on the y-axis, you move straight down from there, and you appear to be somewhere. Where? And you have to kind of guess, right? Somewhere right around, I don't know, 90. That may not be exactly right, but that's okay. We're somewhere in there. So 90 text messages a day would put you about middle of the pack. Okay? If you want to find out how many texts you have to send to be in the 90th percentile, right? You find 90% on the y-axis, slide over to your graph, and then slide down from there, and that'll put you right about, I don't know, 220. Right? And so again, we're just guessing. Okay? Now, here's an ogive with two curves on it. So in this particular ogive, this is the number of days until court disposition. This is if a crime is committed, the number of days it takes for an arrest to be made, and that case to go to trial. So the top line is burglary, the bottom line is robbery. Okay? 30 days, right? After 30 days have gone by, we can go to 30 here on the y-axis or on the x-axis and move up to the ogive for burglary. At 30 days, you can see that about 35% of those crimes have been resulted in an arrest and gone to trial, where only 22% of robberies are at that point, right? So a little bit quicker in burglaries to find who did it and take them to trial, right? Over here, right, at 360 days, after 360 days have gone by, we're over here, about 92% of burglaries have been taken to trial, where only about 85% of robberies have gone to trial, right? 90th percentile, right? That place where 90% of cases have gone to trial. For burglary, it takes about 330 days. Sorry for that bell. For robberies, it takes longer, right? As a matter of fact, the robbery curve hadn't gotten there yet, okay? So just some ways to use. So obviously it takes longer to solve a robbery than it does a burglary. Okay? All right. Just some uses of an ogive. Hopefully that makes sense.